Okay, trig, students, section 9.6, function values of special angles. Um, so, we actually met the 30, 60, 90 right triangle back all the way back in section 9.1. I'm just going to flash this up for you. I went through this process, whether you remember it or not, where we took an equilateral triangle and we realized that if we dropped an altitude down that we split the base, and so that then we went through this whole thing where we did the Pythagorean theorem and we figured out then what the length of the side opposite the 30 and 60 would be, basically. So this is the side opposite the 60 and then the side opposite the 30. So really, if you have a 30, 60, 90 right triangle, try to be clear here. If you call the hypotenuse whatever it may be, the side opposite the 30 is just going to be half of the hypotenuse, and the side opposite the 60 is just going to be the side opposite the 30 slap on a radical 3. So let me see if I can make that simpler over here. I just wanted to hopefully bring that back to you. So when I look at this, I have 30, 60, 90 right triangle. I have a hypotenuse of 1, so the side opposite the 30 is 1/2. And the side opposite the 60 is the side opposite the 30, which is a half, slap on a radical 3. So it would be 1/2 radical 3. But normally, the way we write that, I'm going to write it the normal way, is we would write radical 3 over 2. Okay. The one thing that we didn't discuss yet was a 45, 45, 90. So I'm going to just do a quick figuring of that. So 45, 45, 90 right triangle, we would have two sides that are congruent. So if we wanted to figure out the lengths of those sides, especially in a scenario where the hypotenuse is 1, basically these are the sides I don't know, I'll just call them x. I would have x squared plus x squared, which would equal 1 squared, so that's 1. And so then I would have 2x squared is equal to 1, and I'm going to divide both sides here by 2. And then I'm going to take my square root to get x squared to be x. I'm not going to worry about plus or minus because I am in a triangle, so I'm only talking about measurements here. And so I would end up with 1 over radical 2. And to clear that radical, I'm going to multiply the top and bottom by radical 2 over radical 2, and I get radical 2 over 2. So in this situation here, I have radical 2 over 2, radical 2 over 2. So what today is about is actually getting some what we call exact values. So we don't want to put decimal values down, we want to talk exact values. So I'm going to start here with this 45, 45, 90. And what I want to do is I'm going to just drop this guy on down right into my unit circle. Okay? So here's my unit circle, and I'm going to take that same triangle, I'm making it a little bigger, but it would be a similar triangle. And I'm going to drop that guy right on down here. So because this is the unit circle, the radius is 1. And so when I look back up here then, my x value is radical 2 over 2 and my y value is radical 2 over 2. So remembering that in the unit circle the x value, so I'm marching along here, the x value is my cosine and the y value is my sine to get up here. So I'm going to go ahead and identify this point as radical 2 over 2, radical 2 over 2. Now, if you hit cos 45, sine 45, radical 2 over 2 is not going to appear on your screen, but a decimal is going to appear, which is actually the decimal equivalent of radical 2 over 2. So in a similar way then, I'm going to come on over here, and I'm going to pick up this guy that has an angle of 60 degrees. Once again, since the radius is 1, I can drop this into my unit circle. And I'm going to do the same thing. So I'm going to come over here. I'm going to take this up to 60. I'm going to drop this guy into my unit circle. And I'm going to remember to myself that really what's going on here, if I want to label this point, and when I'm talking about labeling points, I'm labeling this point here for this guy here. And then I'm going to label really where my 60 degrees is, which is right here, is going to be what I'm going to label for this point. And so my x value is a half from my triangle up above, and my y value is radical 3 over 2. So for 60 then, I'm going to label my x value as a half, and my y value is radical 3 over 2. And if you go ahead and hit cosine of 60 on your calc, sure enough, a half will come out. You'll recognize that. And that would mean that the sine of 60 then is radical 3 over 2. And if you hit sine 60, the decimal equivalent will come out, which we'll talk about more in the future. Okay, so last but not least then, I'm going to flop this guy over so I can drop it also down into my unit circle. And I'm going to still have a radius of 1, and I'm going to make this my 30 and this my 60. So in this case then, the side across from the 30 is a half, and then the side across from the 60 is radical 3 over 2. So when I come on down here and I drop this guy into my unit circle, same idea, I have a radius of 1. I can look right back up there at my triangle and realize that my x value is radical 3 over 2 and my y value is a half. So I'm going to go ahead and do that. So radical 3 over 2 and 1/2. And once again, if you hit cosine of 30, and we're talking about this point here on the unit circle, the cosine of 30 is radical 3 over 2, and the sine of 30, you'll recognize easier, is going to be 1/2, which you'll hear me say that a lot because I always remember the sine of 30 is a half, and that leads me into all kinds of good things because then I can remember a lot of these angles that we care about. So I want to just kind of take a walk around the unit circle and label points that I think are important for you to be able to label, and some of them you already know how to label. So I'm going to start over here at 0, or if I take a wrap around it would be 360. So my x value here is 1, and my y value here is 0, so that tells me something about cosine and sine. And so if I come up here to 90, my x value is 0, my y value is 1, so that tells me about cosine and sine. And so now I'm going to come over here to 120, and I'm here to say that from your geometry experience, hopefully, you realize that if I think about what's going on, think of this as the y-axis for a minute. To go from 90 to 60, I'm going 30 degrees, and the same thing is really happening over here. To go from 90 to 120, I'm going 30 degrees. So this point has a lot in common with the point that's going to be for 120, except for the signs, as in the SIG and S's. And so if I basically take this point here and reflect it over my y-axis, really all that's going to change is my x value. So 120 is going to be negative 1/2 for an x value and radical 3 over 2 for a y value. And remembering what we've learned already about the signs of cosine and sine in the different quadrants, this should make sense, because in quadrant 2 we're going to have negative cosines. So I'm going to go ahead then, and I have 135 here, so I'll just use the same color so you can see this. And so basically my 45, this is 45 degrees to the left, and over here I had 45 degrees, so for 135 I'm going to have negative radical 2 over 2, radical 2 over 2. And I come over to 150, and 150 corresponds, and if it's easier for you to think about, you just want to see how they're in the same positions. Basically 150 is 30 degrees up from the x-axis, and so is 30 degrees up. So if I think about this reflection then, 150 degrees then, this point over here would be negative radical 3 over 2, 1/2. And hopefully now you can see how these are going to just sort of march their way around this unit circle. So now I'm going to come over here to 180, and this is going to be negative 1, comma 0. So I know that the cos of 180 is negative 1 and the sine of 180 is 0. And it doesn't really matter where I go from. I'm going to just kind of look up above here because it's easier for me. 150 is basically 30 degrees above. 210 is 30 degrees below. So the values are going to be the same. It's just the signs, SIG and S, that are going to be different. And since I'm hanging out down here in quadrant 3, these guys are going to both be negative. Okay, so now my 45 degree angle, 135 here, 225 here, so I'm 45 degrees below my x-axis. And so now I'm going to see negative radical 2 over 2, negative radical 2 over 2. And then the last one I'm going to bring down is the one that's 60 degrees above the x-axis, 60 degrees below the x-axis. And so 240 then is going to come down as negative 1/2, negative radical 3 over 2. And it is going to become important that you actually are able to say, like, what is the exact value for these different particular angles. Okay, I'm going to come over here last in quadrant 4, and I have 30 degrees, which is 30 above the x-axis, 330, which is 30 below the x-axis, so my y value changes. My x value, the sign is both positive in both cases, but this is going to be a negative 1/2. And then 315, which corresponds to my 45 above. This guy would be 45 below. And so I still have a positive x value, but my y value is negative. So my cosine is positive and my sine is negative. And then last but not least, I have my angle that's going to come down that's 60 degrees above. And then if I look at 300, I'm 60 degrees below. So this point on the unit circle is going to be 1/2 negative radical 3/2. And I would just challenge you also to sort of look at what's going on as, like, you know, when you look at these two guys, for instance, and we can talk more about that in class, and the same thing in the other quadrants. And last thing I want to label here is for 270. And so 270 then has an x value of 0 and a y value of -1. So that right there is labeling unit circle with what we're calling the function values of special angles, and you are going to need to be able to do that. So let's just apply this concept to a couple of these practice down here. Use a counterexample to show that the sine 2 theta is not equal to 2 times the sine of theta. So basically what this means, and maybe you did this last year in geometry, is just find one example to show that this is not equal, and that would be enough to say that they're not equal. So I would propose that we try 30. Okay? So say I let theta equal 30. So that would mean then that 2 times theta would be equal to 2 times 30 would be equal to 60. And so if I then take the sine of 2 theta, that would be the sine of 60, which would be the y value where the terminal side of an angle of 60 degrees crosses the unit circle. So that would be radical 3/2. So now I'm going to do this other one that says 2 times the sine of theta. So 2 times the sine of theta then would be 2 times the sine of 30. And so 2 times the sine of 30, and the sine of 30, which would be the y value for the angle of 30, which is 1/2 sine of 30. Your calc would also tell you that. So 2 times 1/2 is equal to 1. And we can see that this does not equal radical 3/2. So there's at least one theta for which this is not true. I've run out of space, but if I wanted to complete my statement here, there is at least one theta where sine 2 theta does not equal 2 sine theta. So that proves that this is not true. Okay, here's another little journey back into the land of geometry for a minute, just to practice with this. Lengths of diagonals of a rhombus. If the measure of a side is 10 centimeters, then the measure of an angle is 120 degrees. So let's draw a little rhombus. And I would suggest on any of these problems that I'm doing, you could always stop the video and try it yourself, and then turn the video back on and see how you did. So this does require to remember a few things about geometry. So if we have an angle that's 120, I would propose that it would be this angle down here. If you recall, for a rhombus, the diagonals bisect each other, that bisect the angles. So this would be 60 and this would be 60. So if this is 120, and then we know that these angles are supplementary, so then we would have 120 and then the other angle would be 60, which would also be bisected, so I would have a 30 and a 30. And hello, here we have one of these 30, 60, 90 right triangles. So basically, let's just apply what we just reviewed. What are the lengths of the diagonals of a rhombus? If the measure of a side is 10, there you go, measure of a side is 10, and the angle is 120. So if I just for a second here pull this triangle out, this bottom triangle, and I have a 60 and I have a 30 and I know this is 10, this is where we need to start just sort of feeling this. If I have a 30, 60, 90 right triangle and the hypotenuse is 10, the side opposite the 30 is going to be half the hypotenuse, or 5. The side opposite the 60 is going to be the side opposite the 30, which is a 5. Slap on a radical 3. Plain and simple. So, what does that mean then? It means that I have one diagonal that's going to be 5 plus 5, so that would be 10. And I'm going to have another diagonal that is going to be 5 radical 3 times 5 radical 3, or I'm sorry, plus 5 radical 3, which would be 2 times 5 radical 3, or 10 radical 3. So there you go. Okay, so here is kind of a more classic example of where you're going to have to be able to apply this. What is the exact value of sec 30? Now up above we talked nothing about sec, so this goes back to the last section. So in the last section we learned that the secant of 30 has got to be equal to 1 over its reciprocal function, which is cos 30. So now we need to figure out what cos 30 is and say, well, 1 over cos 30, and since we have our fancy unit circle, we can just go on up here and say, well, we know the cosine of 30 is going to be this x value, so that's radical 3 over 2. So 1 over radical 3 over 2, which really just means the reciprocal, so that would be 2 over radical 3. And just to clear that radical, I'm going to multiply top and bottom by radical 3. So we have 2 radical 3 over 3. So this is kind of where this all kind of starts building. It's a reciprocal function. How do we deal with it, but also wanting to be an exact value. Okay, grand finale. Find the exact value, and I'm telling you right now, we'll get this in your head. Whenever you see exact value, it does not mean put a decimal. It means you're probably going to have a radical. So I would suggest maybe try this one if you want. Stop the video and then come back and see how you did. So really what we're going to do here is we're just going to deposit these numbers, and I'm not going to keep scrolling back. You can see it on your own paper. The sine of 60 is radical 3 over 2. The cosine of 30 is radical 3 over 2. The tangent of 60. So now we need to take the sine of 60 over the cosine of 60. So the sine of 60 is radical 3 over 2 over the cosine of 60, which is 1/2. And so now we got a little math to do. So radical 3 times radical 3 square root of something times square root of something is a something. So I have 3 over 4. 2 times 2 is 4. Plus radical 3 over 2. When I divide, I'm just going to flip this to be 2 over 1. So I have these guys get canceled out. So I have 3 over 4 plus radical 3. But normally we wouldn't want to leave it that way. So I'm going to get myself a common denominator, which would be 4. So basically I'm just going to add a 4 to the top and bottom of this guy, because that's really like the number 1 right there. And we get 3 plus 4 radical 3 over 4. And if you were to actually type that in to your calculator, it would be the decimal equivalent if you were to type sine 60 times cos 30 plus tan 60 as an exact value. Okay, so there you have it. Today we don't have Math Excel problems. You should have yet another sheet, which is a blank of what we just went over, and I want you to maybe take a minute, review what we just did, and put that aside and see if you can do it on your own.